So we're at the pointy end of this topic now, and I'm going to use the Cartesian plane to kind of introduce it, but we'll be very much just doing the algebra. Like when we were using the formulas, y minus y1, etc. It was mainly algebra, even though we were representing things on the Cartesian plane. So simultaneous equations, that means equations that happen at the same time, and what we're trying to do is find the one solution that fits both equations. So let me draw for you nice and large Cartesian plane. Now when we draw a straight line, you might recall I've said it several times, what we're actually doing is plotting the solutions for an equation, and each solution has an x value and a y value. And there's an infinite number of those pairs of solutions. But if I add a second line in, just here for example, there is only one solution that is true for both of these equations. You can see it's when they intersect. Whatever point it is that they intersect, let's say that is x equals 6, y equals 1. And how do I draw it? Then that is the solution for these two simultaneous equations. Now you can do it graphically if you would like. You can draw both lines on the Cartesian plane and see where they intersect, and that is a valid method of solution. Today though, we're going to be looking at the substitution method. So we'll make another heading real quick, or maybe make it a subheading, substitution method. Now this is actually the method I use for every single one, but I'd recommend, unless you're pretty comfortable with algebra, only using it if you have one of the variables by itself. So let's just make a note of that before we start. Use this if one variable is the subject which means by itself on one side. E dot G dot let's say you've got y equals 3x plus 2, y is the subject, and we can use this method. If you had, say, 4y plus 2x equals 9, we'll learn about that next lesson, what to do. So, I'm going to show us by example, because again, it's going to be much easier than writing notes about it. Let's do this. Solve simultaneously. That means both of them have to be true at once. Let's say y equals 3x plus 2 and y equals x minus 5. This is going to be one of the easier ones that we'll do, and we'll build it up from here. So solve simultaneously. What we often do is give the equations names 1 and 2. Write them in circles, because we're not talking about the number 1 and the number 2. We are referring to equation 1 and equation 2, and you don't want to accidentally think you're talking about those numbers instead. So, here it says that y equals 3x plus 2, and there's a y down here. If these are both true at the same time, then I know that this is the same as this as well. Because if y equals 3x plus 2 here, then that y must also equal 3x plus 2. So what I write is substitute, I use the word sub, equation 1 into equation 2. Just, this is how we do our working out to say what we've done. And now instead of y, I can write x minus 5 here because that's going to change. But instead of y, I'm going to substitute 3x plus 2 in instead. Now make sure you're on the same page at this point. You might need to pause it and just think about it a bit. If that y is equal to this, then this y must also be equal to this, and so I can write it instead of y. Now I've got an equation with pronumerals on both sides. So I'm going to take x away from both sides. I'm left with 2x plus 2 equals negative 5. Take away 2. 2x equals negative 7. Divide by 2. X equals negative 7 over 2. Alright, at that point I've done half of it. I found half the solution. Then what I'm going to say is sub x equals negative 7 over 2 into, and it's your choice, put it back into 1 or 2. I'm going to put it into number 2 because there's only one x there, so it gets a bit easier. So if we know x is negative 7 over 2, I don't need to write x anymore. I can say y equals negative 7 over 2 minus, was it 5? Yep, negative 7 over 2 minus 5. Which gets us, put it in the calculator, negative 17 over 2. So my solution is, therefore, y equals negative 17 over 2 and x equals negative 7 over 2. That is the point on the graph where both of these lines intersect. Let's just quickly sketch it up here and see if that's true. It's only going to be rough, obviously, because we're not going to get that precise, but 3x plus 2, well, it's going to intersect up here and have, quite a steep gradient. And then this one over here is going to intersect down here and have less steep of a gradient. I'm going to keep going because it's probably going to be down here somewhere. So it's over here. So x is negative 7 over 2, about here, negative 3.5, and negative, what would that be, 8.5. Yeah, and that looks about right. Obviously, that's probably a bit further down the y-axis, but quick sketch. Looks like we've got it correct. So this point here is the only time that both these statements up the top, equation 1 and equation 2, are true. It's when x equals negative 7 over 2 and y equals negative 17 over 2. Alright, we're going to have a go and step it up a bit. So let's say, e.g., find the solution for the equations. Let's say y equals 3x minus 5 and x equals, let's say, 2 minus y. Make it easy again to start with. Alright, so first of all, label it equation 1, equation 2, and then let's do our working out. Which one are we going to substitute into which equation? Well, it doesn't matter. Both are going to work here just fine. Let's sub 2 into 1. And you can see how I'm putting them in the circles because I'm not subbing the number 2 in, I'm subbing equation 2 in. So in equation 2, x equals 2 minus y. There's an x here. So that x must equal 2 minus y. So I'm going to rewrite equation 1 and I'm going to say x equals 3 times, sorry, y equals 3 times. Well, instead of x, I'm writing 2 minus y. So remember, x equals all of 2 minus y. It needs to be in the brackets. Minus 5. I reckon the brackets will be our biggest point of error in this question. So I expand the brackets. 3 times 2 is 6. 3 times negative y is negative 3y. And then 3 doesn't times the minus 5 because it's not in brackets. That's just minus 5. So y equals 1 minus 3y. Add 3y to both sides. 4y equals 1. let me just say what I'm doing here. I added 3y because remember we add the smaller one and negative 3 is smaller than 1. And then divide by 4, 1/4. Because that's the inverse of times by 4. Okay. Now I know what my y value is. So I know when these two intersect, they are hitting at 1/4 above, 1/4 up the y-axis. Just need to figure out the x value. Let's use 2, because that's going to be nice and easy. 2 minus 1/4. So sub y equals 1/4 into 2. You get x equals 2 minus, well, instead of y, which was up here, I'm using my new value for y, 1/4. And that's going to equal 7/4. So therefore, x equals 7/4 and y equals 1/4. That is the only time that both these equations are true at the same time. Everywhere else, you can solve one of them but not the other. But at this point, they cross over and we've solved them simultaneously. Let's do one more slightly harder one and then I'll hand it over to you guys. So, let's do that thing again. Alright, E.G. Solve. Let's say solve simultaneously. Y equals 4x plus 3 and 3y minus 2x equals 8. Let's call that equation 1, equation 2, and get solving. Now this is the only one I can use at this point because y is by itself, no pronumeral is by itself at this point. So I'm going to have to sub equation 1 into equation 2. No other way to do this one using substitution. Now y is the same as 4x plus 3, so instead of this y I'm going to be writing 4x plus 3. Remember though, brackets, because it's 3 times all of y, which is all of that, minus 2x equals 8. 12x, I'm expanding the brackets, plus 9, minus 2x equals 8. Actually, this one's going to work out pretty easy. 10x plus 9 equals 8. 10x equals negative 1. X equals negative 1/10. Alright, I would put it into the first one. Just looks a bit easier. Sub x equals negative 1/10 into number 1, y equals 4 times negative 1/10 plus 3. What's that? Negative 4 over 10. So we're taking that away. It's 30 over. What's that become? When we're doing over 10. 30 over 3, taking away 4 of them, so 26 over 30, which is the same as 13 over 15. There we go. X equals negative 1/10. Y equals 13 over 15. Alright, that is the only point, only solution where these two are true at the same time. We're going to have a go at some class kick now, so look at the code, have a go, and then we'll do questions from the textbook. Good luck.